Okay, in 6.3, we have already talked about the properties, special properties of parallelograms. Today, what we're going to be doing is proving that something is a parallelogram. And this is always difficult for students because guess what? Quadrilaterals are going to look a lot like parallelograms, but we have to actually prove that it is absolutely a parallelogram and nothing else. So yesterday we talked about 6 properties of a parallelogram, and those 6 properties are going to help us prove that something is a parallelogram. So there are 6 ways to prove something is a parallelogram. Or you can always look for congruent triangles. All right? Okay, so the first thing, obviously, since the definition of a parallelogram is what? The definition of a parallelogram is that both opposite sides are parallel. So if both sets of opposite sides are parallel, it will always be a parallelogram. That's the first thing to show that it's something is a parallelogram. So I'm going to draw a parallelogram for you. Does this look like a parallelogram? Yeah, it does, but right now I haven't given you any information, so we cannot tell. However, if I put the parallel signs like this, then now we can say, yes, most definitely this is a parallelogram since both sides, opposite sides are parallel. The second way to prove that something is a parallelogram is if both opposite sides are congruent, then it will make a parallelogram. So, if I tell you that this side is congruent to this side, and this side is congruent to this side, then yes, most definitely it will have to be a parallelogram. But some people are going, well, why? Why is it a parallelogram? Let's look at the diagonal for a second. Because again, I said we want to always try to look for congruent triangles. So if we look for a congruent triangle, if we draw this diagonal, we have 2 triangles that are congruent by SSS. If we have congruent triangles, that means by CPCTC, so we said by SSS, these triangles are congruent to each other. By CPCTC, that means corresponding parts of congruent triangles are congruent. So that means that this angle will be congruent to this angle, and this angle is going to be congruent to this angle. Now, are these angles alternate interior angles? Yeah, so that means this side will be parallel to this side, and this side will be parallel to this side, which makes it a parallelogram. Sweet. So again, all we knew were the opposite sides were congruent, and then we determined that it was a parallelogram. So that's the second way to prove something is a parallelogram. The third way, what happens if we just know about one side? And we know that, one opposite set of opposite sides. Pair or whatever, opposite sides. Let's say that they are both parallel and congruent. Can we determine that that is a parallelogram? So what we're saying right here is that this side is congruent to this side and they're also parallel. Well, if they're parallel, what do we always have? We always have alternate interior angles. So we know that this angle will be congruent to this angle. And we know that this side is congruent to this side. Do we have congruent triangles? Yeah, we have a side, we have an angle, and we have a side. So we have congruent triangles. So by SAS, the triangles are congruent. By CPCTC, we know that corresponding parts are congruent. So that means these angles are going to be congruent to each other, which means these sides have to be parallel. And again, we have a parallelogram. That's the third thing. The fourth thing, let's say we only know about the angles. If we know that both sets of opposite angles are congruent to each other, we will have a parallelogram. So what that means is if I know this angle is congruent to this angle, and if I know that this angle is congruent to this angle, then we're going to have a parallelogram. Okay, but we have to know about both of them. So some people are going to think that this is a parallelogram. They're going to think that this is a parallelogram. Right here, like this. But it's not necessarily a parallelogram because if you look at the diagonal, we don't have enough information. We only have an angle on a side, and that doesn't prove that the triangles are congruent, so it does not make a parallelogram. This is a parallelogram, this is not a parallelogram. The fifth way is if we know one angle is supplementary to both consecutive angles, then it'll be a parallelogram. So what that means is, if I know that this is 80 degrees right here, and this is 80 degrees, cool, we have one set of opposite congruent angles. If I know that this is 100 degrees, how many degrees are there in all quadrilaterals? 360. So if you add those up and subtract it from 360, you're going to get 100 degrees. So we have opposite angles are congruent, which makes it a parallelogram. If you only know about one set, though, if you only know this, then you're not necessarily going to have a parallelogram, because these angles could be whatever you wanted them to be. Okay, and then the sixth and final way to prove that a parallelogram is something is a parallelogram is to look at the diagonals. Remember, the diagonals must bisect each other, and then that will give you a parallelogram. So let's look at some examples and some non-examples. So for this one, we have one angle is supplementary to both of its consecutive angles. So yes, it is a parallelogram. Right. Let's look at this one. This one, we only know that one set of angles are congruent. We need to know about both sets. So if we looked at congruent triangles, these triangles are not congruent to each other, so this is not a parallelogram. Say we had this one. Again, if we look for congruent triangles, we have two different triangles. This triangle is not congruent to this triangle. This is not a parallelogram. If we look at something like this, again, if you're not sure, always look for congruent triangles. So we have this side is congruent to itself by the reflexive property. We have angle, angle, side, and angle, angle, side. These ones are congruent. So we have congruent triangles. So that means that this side will be congruent to this side by CPCTC, and this side will be congruent to this side by CPCTC. We have opposite sides that are congruent. So we have a parallelogram. All right. The last thing you're going to be doing is proving that something is a parallelogram in the coordinate plane. And to do that, you need to look at the slopes of the sides, because the definition of a parallelogram is that the opposite sides are parallel. And to prove lines are parallel, they must have the same slope. So if you want to graph it, you just count rise over run. If you don't want to graph it, you have to use the slope formula, y2 minus y1 over x2 minus x1. Oops, minus x1. So if you look at, remember in geometry, we go in a clockwise order, so K, L, M, N is what this parallelogram is going to look like. So we know that the opposite sides are KL and MN, and we know that they are LM and KN. So you have to do the slope 4 times. So if I did the slope for KL, that would be the y's are 0 and 7, and the x's are -3 and a -5. So this is going to be -7 over 2. And then if we do it for MN, the y's are 5 and a -2. The x's are 3 and a 5. So we have 7 over -2. And so their slopes are congruent, are equal, so these lines are parallel. Do the same thing for LM. So the y's are 7 and 5, and the x's are -5 and 3. So that comes out to be 2 over -8, or -1/4. And Kn is the y's, are 0 and -2. And the x's are -3 and -5. So we get, again, 2 over -8, which is -1/4. And these are parallel, which makes it a parallelogram.